Let us solve a very important question. Cos alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta by vector method. So let us draw a diagram here. I have taken the coordinate A in the first quadrant, where OA is equal to A cap, where the modulus value for A cap is equal to 1. B in the fourth quadrant, taking OB vector is equal to B cap. A makes an angle alpha with the x-axis and B makes an angle beta with the x-axis. I and J are the unit vectors along the x-axis and y-axis. Now this angle AOB will be is equal to alpha plus beta. Now from the diagram, let us write the values. Draw a perpendicular from A to L on the x-axis and B to M on the x-axis. Now taking the triangle, upper triangle, in triangle OAL, we find what is cos alpha. Cos alpha will be is equal to the adjacent side for the triangle, which takes the direction from O to x-axis. So that is equal to modulus of OL vector divided by modulus of OA vector. OA vector will be is equal to A cap. We know the modulus of A cap is equal to 1, which gives us OL vector will be is equal to cos alpha. So we have found the value for the x coordinate. Similarly, from the diagram, sine of alpha will be is equal to the opposite side, that is AL vector, that is equal to LA vector. The direction is from L to A. Direction is very important here. The direction in the upper triangle is O to L, L to A, and the resultant vector will be OA vector. Direction is from O to A. So we have found what is cos alpha. We have found what is sin alpha here. Next we find what is sin beta and cos beta from the diagram in the triangle OBM. We find what is cos alpha. Cos alpha will be is equal to the adjacent side, that is OM vector, divided by modulus of OB cap, that is modulus of OB vector. OB vector is equal to 1. So we get OM vector will be is equal to cos alpha. Similarly, the sin alpha from the diagram, sin beta here, B makes an angle beta. So sin beta will be is equal to the opposite side, that is MB vector. Direction is from M to B. So here MB vector divided by OB vector, which is equal to 1. So we get MB vector will be is equal to sin beta into MB vector is equal to sin beta. We have found all the values. Now let us write the coordinates of A and B here. So the coordinates of A will be is equal to cos alpha sin alpha. Both are positive in the first quadrant. And B, here this is negative of J cap because it is the unit vector in the negative side of the y-axis. Therefore, coordinates of B will be is equal to cos beta comma minus sin beta. Now let us write all the values we have found here. The coordinates of A are cos alpha sin alpha, coordinates of B is cos beta minus sin beta, and now we want the dot product of A and B. So here OA vector, which is equal to A cap, will be is equal to, from the diagram, that is equal to OL vector plus LA vector, which is equal to cos alpha I cap, unit vector in the direction, plus sin alpha J cap. Similarly, OB vector will be is equal to B cap, which is equal to OM vector plus MB vector, which is equal to cos beta I cap plus sin beta of minus J, which gives us minus sin beta J cap. Now we take the dot product of A vector dot B vector, that is A cap dot B cap, will be is equal to cos alpha I cap, taking dot product of both the vectors, which gives us cos alpha cos beta. I dot I will be is equal to 1, we know, minus sin alpha sin beta. This is equation number 1. Next, by the definition of dot product, we know that A cap dot B cap dot product will be is equal to modulus of A cap modulus of B cap into cos of angle between both the vectors, that is cos of alpha plus beta, which gives us this is equal to 1 into cos of alpha plus beta. Therefore, from 1 and 2, we see that LHS is the same. Therefore, we get the result cos of alpha plus beta is equal to cos alpha cos beta minus sin alpha sin beta. Such a simple and important question. Cos, whenever cos comes, we take the dot product, and sin, we have to take the cross to the adjacent side, that is equal to OL vector divided by OA vector. OA vector is equal to A cap. A cap is equal to 1, which gives us cos alpha will be is equal to OL. Similarly, sin alpha from the diagram, sin alpha will be is equal to the LA vector divided by modulus of A vector. So that is equal to sin alpha will be is equal to LA vector. In triangle, taking the other triangle, triangle OBM, we get sin cos of beta will be is equal to adjacent side OM vector divided by OB vector. OB vector is equal to B cap, which gives us OM vector will be is equal to cos alpha, cos beta. OM vector is equal to cos beta, and therefore we get sin beta will be is equal to opposite side, that is MB vector divided by the hypotenuse is OB vector divided by OB vector. Is modulus of B cap value is 1. So we get sin beta will be is equal to MB vector. All these values we have seen in the previous problem itself. Now coming to our question, let us write. OA vector is equal to A cap, OB vector is equal to B cap, the unit vector. The coordinates of A will be cos alpha, sin alpha. In the first quadrant, both are positive. Coordinates of B making an angle beta with x-axis is cos beta, comma, sin beta, both are positive. Now let us write what is OA vector. OA vector will be is equal to A cap, which is equal to OL vector plus LA vector as the previous problem. So that is equal to, from the coordinates, we can write cos alpha I cap plus sin alpha j cap. I and j are the unit vectors along x and y axis, and OB vector will be is equal to B cap, which is equal to OM vector plus MB vector. So that is equal to cos beta I cap plus sin beta j cap. Now let us find, since this is cos of alpha minus beta, we take the dot product A cap dot B cap. From these values will be, so taking the dot product, we get A dot B is equal to cos alpha cos beta plus sin alpha sin beta. I dot I is 1, D dot J is 1. So we get the product A dot B is equal to cos alpha cos beta plus sin alpha sin beta. By definition of dot product, A dot B will be is equal, by definition, A cap dot B cap is equal to modulus of A cap modulus of B cap into cos of the angle between both the vectors. So we get A cap dot B cap is equal to cos of alpha minus beta. Now we see from 1 and 2 that LHS is the same. Therefore, we get cos of alpha minus beta is equal to cos alpha cos beta plus sin alpha sin beta. Next question, sin of alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Diagram is the same as alpha plus beta we saw in the cos of alpha plus beta problem, first problem. So taking OA is equal to A cap, OB is equal to B cap. Draw perpendiculars from A to L on x-axis, B to M on the x-axis. A makes an angle alpha with the x-axis and B makes an angle beta with the x-axis. So as the previous sum, we have seen that the coordinates of A will be cos alpha, sin alpha in the first quadrant. Fourth quadrant, B will be cos beta, comma, minus sin beta. Cos positive, sin negative in the fourth quadrant. Now coming to the problem, we'll write what we have. Coordinates of A and B, we have written angle AOB is equal to alpha plus beta. So from the diagram, we'll find what is A cap. A cap will be is equal to OA vector, which is nothing but is equal to OL vector plus LA vector, which is equal to, the direction is from L to A and from M to B in the diagram. So that is equal to cos alpha I cap plus sin alpha j cap. Next, we find what is B cap. B cap will be is equal to OB vector, which is equal to OM vector plus MB vector, which is equal to cos beta I cap minus sin beta into the unit vector in the direction, that is equal to j cap. Now for sin, we take the cross product here. Cross product B must be taken first. This is very important to notice that. B cap cross A cap. Cross product, we know to take the cross product in the determinant form, taking the first row as a unit vectors ijk, components of B vector to be taken in the second row. First B vector components, that is cos beta minus sin beta, and there is no k cap, so we take 0 here. Components of A cap will be is equal to cos alpha, sin alpha, and 0. Expanding the determinant, this is equal to I cap into 0 minus j cap into 0 plus k cap into we get, that is taking the cross product, that is equal to sin alpha cos beta minus of minus, so plus cos alpha sin beta. Now this gives us, this is equal to k cap into sin alpha cos beta plus cos alpha sin beta. This we take it as equation number 1. Now from the definition of cross product, we know that by definition B cap cross A cap will be is equal to modulus of B cap modulus of A cap into sine of angle between the vectors, that is alpha plus beta, into K cap. We know that A vector cross B vector will be is equal to modulus of A vector modulus of B vector sine theta into n cap, the vector normal vector to the plane of A cap and B cap. So we are using the definition here. Modulus of the unit vectors is 1, so 1 into sine of alpha plus beta into K cap. This is equal to B cap cross A cap. From 1 and 2, we see that B cross K cross A cap from equation number 1, B cap cross A cap from equation number 2, the LHS are equal. Therefore, comparing the given two terms, we get sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. The next question, sin of alpha minus beta is equal to sin alpha cos beta minus cos alpha sin beta. Diagram is the same as cos of alpha minus beta. So we have taken the diagram. OA is equal to A cap, making an angle alpha with x-axis. OB is equal to B cap, which makes an angle beta with the x-axis. Draw perpendicular to A to L on x-axis, B to M on the x-axis. The direction in the triangle OAL is from O to L, L to A, and O to A. Similarly, in the triangle OBM, direction is from O to M and M to B and O to B. So coordinates of A and B both are in the first quadrant, and therefore cos alpha sin alpha coordinates of A and coordinates of B will be cos beta sin beta. Here we are going to find what is A cap. A cap is equal to OA vector, which is equal to, like the previous problem, that is equal to OL vector plus LA vector, which is equal to the first coordinate, that is cos alpha I cap plus sin alpha j cap. Similarly, B cap is equal to OB vector, which is equal to OM vector plus MB vector, which is equal to cos beta I cap plus sin beta j cap. Now for sin, as we told, we are going to take the cross product, B cap cross A cap, which is equal to the I cap, J cap, K cap. Next coordinates, components of B cap will be is equal to cos beta, sin beta, 0, and components of A cap will be is equal to cos alpha, sin alpha, 0. Expanding the determinant, we get I cap into 0 minus J cap into 0 plus K cap into, we take multiply the elements here, that will be is equal to sin alpha cos beta minus cos alpha sin beta. Cross A. Now by definition of the cross product, B cap cross A cap will be is equal to modulus of A cap modulus of B cap into sine of the angle between both the vectors. The angle between both the vectors is alpha minus beta, and therefore this is alpha minus beta into K cap, the normal vector. So this is equal to, unit vector is 1. We get sine of alpha minus beta into K cap. From 1 and 2, we see that sine of alpha minus beta is equal to sine alpha cos beta minus cos alpha sin beta. The next important question, prove by vector method that the perpendiculars or altitudes from the vertices to opposite sides of a triangle are concurrent. So in the diagram ABC are the vertices of the triangle and AD is perpendicular to the base BC and B is perpendicular to the base CA. We are asked to prove that the perpendicular from C also passes through the point O. So we have to prove that CF is perpendicular to the base which is BA. So let us take let OA is equal to A vector, OB as B vector and OC as C vector. Now the vector directed from the vertex A is perpendicular to the base BC, that is AD is perpendicular to BC, or we can say A vector is perpendicular to BC vector. So perpendicular condition A dot BC vector is equal to 0, which implies A vector dot BC vector can be written as OC vector minus OB vector is equal to 0, which gives us A vector dot C vector minus B vector is equal to 0, which implies that A vector dot C vector minus A vector dot B vector is equal to 0. This is equation number 1. Similarly, we can say that this B vector is perpendicular to the base CA, or this B vector, that is, it is directed from OB vector dot CA vector are perpendicular, therefore dot product is equal to 0, which gives us B vector dot CA vector can be written as OA vector minus OC vector is equal to 0. Equating to 0 is very important. Dot product is 0, then only vectors are perpendicular. So which can again be written as B vector dot A vector minus C vector is equal to 0, which gives us B vector dot A vector minus B vector dot C vector is equal to 0. Now let us take this as equation number 2. So if adding the equations 1 and 2, we get 1 plus 2 gives us A vector dot C vector minus A vector dot B vector. LHS add both. So B vector dot A vector minus B vector dot C vector is equal to 0. A B vector and A dot B and B dot A both are same since the dot product is commutative. So the values get cancelled and we are left out with A vector dot C vector minus B vector dot C vector is equal to 0, which gives us A vector minus B vector dot C vector is equal to 0. A vector can be written as OA vector minus OB vector dot C vector. OC can be written as OC vector, which is equal to 0, which can be written as BA vector. OA vector minus OB vector is BA vector dot OC vector is equal to 0, or BA vector can be written in other words as BA vector dot OC. OC is directed from the vertex C and therefore it can be written as BA vector dot CF vector is equal to 0, which gives us the result that BA vector is perpendicular to CF vector. So we have proved that the other altitude is also perpendicular to the base and therefore we can say that the altitudes which are directed from the vertices of a triangle are concurrent.